So I've got an even numbered problem from your textbook up on the board. It's number 2. We're integrating over the curve C, x over y with respect to arc length S. And the curve is described this way. So we're given parametric equations for it. I'm just going to immediately rewrite that as a vector function. That means r of t is t cubed, t to the 4th. Okay. And then I can find r prime of t. That's going to be 3t squared, 4t cubed. And I can find the magnitude of r prime of t. I'm going to need that because when I switch from integrating ds to dt, I'm going to need to multiply by the magnitude of r prime. I'm going to sort of refer to this as my scaling factor. Okay, so ds is a change in arc length. It's not the same as dt, which is a change in usually time. Okay, and so when I switch from ds to dt, I introduce this scaling factor. We're essentially saying that arc length is a multiple of the change in time, or ds is a multiple of dt. Now, it's not a constant multiple. Most of the time when we evaluate this, this is going to be a function. So I'm not saying that arc length is always twice the change in t. It's a multiple, but it's a changing multiple. At different moments in time, I might be stretching, and at other moments in time, I might be shrinking the change in t in order to get the arc length. All right, so this is going to be the square root of 9t to the 4th plus 16t to the 6th. I'm going to simplify that a little bit. Looks like I can factor out a t to the 4th under that radical. And then it's times 9 plus 16t squared. And the square root of t to the 4th would just be the absolute value of t squared times root 9 plus 16t squared. And of course, t squared is always positive. So that's just t squared times the square root of 9 plus 16t squared. Okay, so that's the work that I'm going to need in order to rewrite this. So now we've got our r of t, and of course t was varying from 1 to 2. So now I'm going to integrate from 1 to 2. I need to take the original integrand and write it in terms of t. So x was t cubed over y was t to the 4th. And then we get our scaling factor dt. And the scaling factor is what we just calculated. That's the magnitude of r prime of t. That's going to be our t squared root 9 plus 16t squared. Okay, so let's see if we can't simplify the integrand a bit. One thing with arc length, with line integrals, is you're getting always the magnitude of r prime, which is going to be this quantity under the square root. That can lead to some nasty integrals. I'm going to hope that things work out fairly nicely, and often they do. But it's really important that in converting things to an integral with respect to t, I convert correctly. Because a simple mistake could lead to a really, really nasty integral just because of the presence of that square root. Okay. All right, let's see. So this is the integral from 1 to 2. Looks like I've got a total of 5 t's on top and 4 on bottom. So I can cancel, and that leaves me just one factor of t. Root 9 plus 16t squared dt. And this one's going to be very nice because I can use that t in a u sub. So let's let u equal 9 plus 16t squared. Du then is going to be 32t dt. So I need a factor of 32. I'll counterbalance with a 1/32 on the outside. And now I can say this is 1 over 32 integral from the u value at 1, which would be 9 plus 16 is 25, to the u value at 2, which is going to be, let's see, 2 squared is 4, times 16 is 64, plus 9 is going to be 73. The 32t dt, that's my du, and this is just the square root of u, which I'll write as u to the 1/2. So we get 1/32 times 2/3 u to the 3/2 evaluated between 73 and 25. So let's see, I can do a little bit of canceling here. So that's going to be 1/48 times 73 to the 3/2 minus 25 to the 3/2. And remember my rule for fractional exponents. If the root part is nice, you got to simplify. If the root part is messy, you can leave it. So here, the root part would have me taking the square root of 73. That's messy. I'm leaving it. Here, the root part has me taking the square root of 25. That would be 5. And then I cube it. That gives me 125. So I'm going to say this is 1/48 times 73 to the 3/2 minus 125. And that would be simplified as far as you need to go.